Hello my friends, welcome to my Energy Economist channel. In this video we are going to talk about drilling rigs, so stay with me. Rigs are classified according to type, bottom supported, floating, environmental capacity, harsh, moderate, water depth, and specification, standard, premium. MODUs are classified as bottom supported or floating rigs. In bottom supported units, the rig is in contact with the seafloor during drilling, while a floating rig floats over the site while it drills, held in position by anchors or equipped with thrusters using dynamic positioning. Bottom-supported units are used for shallow water drilling and include barges, submersibles and jackups. Floaters are used for deep water drilling and include semisubmersibles and drill ships. Jackups, drill ships, and semisubmersibles comprise the majority of the offshore fleet. Rigs are classified as harsh or moderate environment units. Harsh environments are characterized by frequent and severe storms as occurred during winter in the Northern Hemisphere, North Sea, Norwegian Sea, North Pacific, Eastern Canada. In the Gulf of Mexico and much of Asia, moderate environmental conditions predominate for most of the year, but tropical storms may cause severe weather events. In Brazil, Australia, West Africa and the Persian Gulf, severe weather is rare. In order to work efficiently in a region, a rig must be capable of operating during average 1-year storm conditions and surviving 100-year storm conditions due to tropical storms. The 100-year storm conditions in the North Sea are similar to conditions in the Gulf of Mexico and Asia. However, 1-year storm conditions are far more severe in the North Sea. As a result, harsh and moderate environment rigs differ in maximum operating conditions but do not differ in maximum survival conditions. Harsh environment units have a number of design modifications to decrease weather-related downtime, including increased variable load to reduce the need for resupply, increased air gap to increase wave clearance, and changes in the geometry and spacing of the legs and columns to decrease wind and wave loads. Harsh environment rigs are larger, heavier and more expensive to construct and operate than moderate units. Drilling operation is mainly of two types, namely, exploratory and development, depending on the purpose and type of wells. Exploratory drilling is usually carried out in the virgin area or in the field whose lithology or subsurface characteristics are unknown. On the other hand, development drilling is undertaken in a producing field with known reservoir characteristics to enhance production capacity. Based on capacity, depth of drilling, and size of production hole, rigs are categorized as shallow or deep drilling rig. Similarly, depending on the type of operation performed, on-land rigs are termed as drilling or workover rigs. Old wells occasionally require maintenance and recompletion jobs, especially in matured fields that include revival of sick wells, water shutoff jobs, well deepening, sidetracking, fishing, servicing, and so on, that necessitate working over the wells. These jobs are generally done with smaller-sized, cheaper rig with lesser footprint called workover rig. A deep drilling rig consists of large-sized modules and high-capacity equipment like drawwork, engine, mud pump, mud system, traveling block, crown block, swivel, rotary table, and huge and tall tower called derrick, apart from varied downhole tubular such as drill pipe, collar, stabilizer, jar, and so on. A shallow or development drilling rig has a smaller-sized module as compared to a deep drilling rig. Workover rigs, on the other hand, are generally truck-mounted and have much lesser equipment. The on-land drilling rigs are of various types, which may be broadly termed as mobile rig, desert rig on wheels, and rig with high floor masts and substructure, all of which are elaborated as follows. 1. Mobile rig. This type of rig is mounted on wheeled carrier and has telescopic mast, which can be driven to the desired location along with equipment, engines, and other accessories. It is used for drilling shallow wells. Rig move time ranges between 16 and 24 h within a distance of 4 to 5 kilometers. 2. Desert rig on wheels. There are various combinations of rig types depending on capacity, need, varying, heavy, loads on wheels, partially or fully disassembled units, and so forth, for which rig move time would also vary. Desert rig on wheels that moves with mast in erect condition takes around 1 to 2 days for rig move within the same area. Desert rig that moves with mast down condition takes around 3 to 4 days. 3. Rigs with high floor mast and substructure. These are usually higher capacity rigs used for drilling deeper wells. The rig components are dismantled and transported to the new location by heavy-duty trucks and trailers. Rig move time varies from 1 to 2 weeks depending on the design and capacity of the rig. The current study specifies rig move activities of 1500/2000 HP desert electrical rig on wheels with fully disassembled units, drilling depth capacity 16,000/20,000 feet. Platform rig. The decision to use a platform rig should be made prior to the design of the platform. This decision would be influenced by size of field, depth of production, radius of drainage of platform, volume of production, availability of rigs and water depth. The platform rig would consist of the basic rig components with the living accommodations being part of the platform. This would require additional space and strength to handle the loads imposed. The day cost of this type rig would be less than others but could be offset by the additional expense of the platform. The rig would be, perhaps, a land rig that would be loaded on a barge and towed to the platform. It would then be hoisted onto the platform and positioned over the well template for drilling. Jack-up rig. The decisions to use a jack-up rig would be influenced by the same actors, but generally a lesser number of wells in shallow water would be strongly in favor of the jack-up. The platform design should allow sufficient room to position the jack-up around the platform without damaging it. This would require the operator to look at a particular rig and sign a contract for this rig in order to assure the compatibility of the two. The rig would be spotted near the platform with tugs and workboats. The rig anchor system would be put out and the tugs would assist in spotting the rig over the platform. The rig anchor pattern should ensure good holding power and not interfere with the normal operations of the platform such as pipelines, crew and workboats, etc. Anchor piles are sometimes installed on the platform to reduce the anchor handling problem. Semisubmersibles. The increased depth of operational waters has been met with the semisubmersibles. The development of subsea equipment has been such that the continued use of the semis is ensured. The semi, or floater, as it is sometimes referred to, is towed to the location buoy and spotted. The tugs will run the anchor pattern that has been previously selected for minimum interference with operations and weather. The semisubmersible will then be positioned over the proper location and maintain its position automatically within preset limits. Some are self-propelled or have thrusters to assist in towing. The self-propelled speed is generally low, and some government regulations require tugs. The semisubmersibles have very good motion characteristics that permit drilling operations to continue in waves of 35 to 40 feet high. Wind and current forces tend to push the unit off location. This calls for a heavy mooring system that uses chains instead of wire rope and 45,000 pounds anchors. This system requires good handling. In the United States, the Coast Guard has been assigned the responsibility for developing measures to ensure the safety of life at sea. The American Bureau of Shipping, ABS, determines the maximum safe draft to which a drilling unit may be loaded and requires that a visible marking be placed on the vessel at this draft. This maximum draft, or load line, is indicated by the Plimsoll mark. Samuel Plimsoll was a member of the British Parliament and was largely responsible for the passage of the British Merchant Shipping Act of 1876. This act called for the placing of a mark at the maximum safe draft in order that all persons on board the vessel could see that it was not overloaded. Drill ship. Drill ship is a ship with the center part hollowed out for drilling activity. This moonpool area is positioned by the ship's power system and maintained within predetermined limits. Drill ships are generally used for the remote wildcat type operations, or in very deep water, or for scientific exploration. The water depth is limited only by its mooring system. Wind, wave, and current action tends to force the unit off its location. A mooring system of up to 10 anchors and mooring lines could be used to offset forces in any direction. The deployment and recovery of this system is difficult and hazardous. It cannot be accomplished safely in waves of more than 8 to 10 feet. Drill ships are the least expensive floating units to build by conventional mooring. The addition of dynamic positioning increases construction costs substantially, but no other alternative is presently available for ultra-deep water. The disadvantage to the drill's hip is its susceptibility to wave action. In 20 to 25 foot waves, the vessel may heave 8 to 10 feet. Drilling operations are usually suspended when heave reaches 5 to 7 feet, so in rough water areas much of the time is spent waiting on the weather. Submersible rig. The submersible rig is similar to the jackup rig in that they both rest on the bottom. The submersible has hulls on which it floats while being towed to the location. Upon reaching the location, the hulls are flooded and sunk to rest on the bottom. The drilling deck is supported by columns from the hull and is well above the water level. Submersibles have a fixed operating water depth like the jackups, and both are limited to drilling in relatively shallow waters. The submersible and jackup rigs provide a very stable platform for operations. Upon reaching its location, the submersible is submerged by flooding one end of the hull to a reasonable tilt angle. The other end is then flooded, and the vessel is more or less rocked to bottom. The drilling deck must be at such an elevation that the waves can pass safely underneath. On leaving the location, the submerging process is reversed. Some units submerge at a nearly level condition. Upon reaching the seafloor, the unit is leveled and all tanks are flooded to bring the unit to the desired bearing load on the bottom. Care must be taken to ballast or de-ballast the unit evenly about the center line. Too much weight on one side can bring the unit to the surface heeling to one side. Planning can eliminate this problem. A careful operator knows the weight of the unit and how much ballast must be removed to cause it to float freely off bottom. As the unit starts to break suction from the seafloor, observant rig personnel can detect the first movement of the unit as it starts to move with the waves. The de-ballasting operation should be stopped. The force of the sea gradually causes water to permeate the soil beneath the hull and allows the unit to float. The unit is then raised to the surface. If you want to learn more about drilling rigs, you could do so in my book, Economic Study of Oil and Gas Well Drilling, which is published on Amazon. Check it out at the link in the description. Please take a second to hit the like button, hit the subscribe button, and do not forget to also hit the notification bell. Thank you for watching and goodbye.